So let's look at part 3. The number of 40 marks produced each day is independent of other days. So every day you take 50 marks, right? So just imagine part 3. Okay, you have got 1, 2, 3. How many days do you have? We have 5 days in a week, working week. Okay, so this case here, every day it's just F binomial 50 and 8%. Okay, same thing if this is F2 binomial 50 and 8%. And so on. So F3 and F4 and F5. Okay. Now you're told that find the probability that in the randomly chosen week of 5 days, at least 7 marks are found. At least 40 marks are found on no more than 2 days. So you whether a day would have 7. The condition here is at least 7 marks are found on a day or not, whether you satisfy this condition or not, right? So let me just write down, this is like a binomial within a binomial. It's a very typical question. So let x be the number of days which have at least 7 40 marks out of 5 days. Okay, so the condition here is to satisfy this this condition here. So in other words, you have x. A week has got 5 days, right? Okay, each time you need to satisfy the condition where f is at least 7 40 marks. Okay, that's it. So x is a binomial. So just use more than 3SF here. So what was it? 101781. I'm just gonna be a bit kiasu here and just put 101871. Okay, and yeah, that's about it. Probability at no more than 2 days. I found on no more than 2 days. So required probability. Probably the range is at least 7 marks are found no more than 2 days. So px less than at most 2, no more than 2, so it could be 2. So key calculator, this case here would be binomial CDF, and trial is 5, and this would just be 101871, 0.101871. hopefully is correct. This is 2, 0.9909, 0.99097, 0.991. Yes, so this is how you do this question here proficiently.